Hi, this is Mrs. Jones, and we're going to be doing a review for the test over angles, and it covers parallel lines with a transversal, which is this one, and also with similar angles with the triangles. Okay, so let's go over this part first. Some things that you need to make sure and remember is that the vertical angles are congruent. Vertical angles would be angles that are directly across from each other, like these gold angles. Those are vertical. Like this peach angle and that peach angle, those are vertical. Okay? You need to remember that alternate exterior angles are congruent. That would be like this angle and this one out here. They're on the exterior part of the parallel lines, and they alternate on either side of the transversal. Those are congruent and the same. Alternate interior lines, like here and here, or alternate interior angles, those are also congruent because they both are inside of the parallel lines, and they alternate on either side of the transversal. And the final type that we learned are the corresponding angles. That's like this orange and this orange here. Those angles are congruent because they're corresponding. They're on the same side of the transversal, and they're both above a parallel line. And then like this orange and this orange are examples of corresponding angles because they're both on that side of the transversal, and they're both below a parallel line. So basically every orange angle up here, they're all the same, and every peach angle is the same. Okay, so let's look at an example of a problem. And so let's say that I have 3x is this angle right in here, and then this angle over here is 5x minus 76, and I'm going to solve for x. Well, since these two angles are alternate interior, they're both inside the parallel lines, alternate on either side of the transversal, they're equal, and they're both orange. So when I solve for x, I'm going to set those two mathematical expressions equal to one another. And then I'm going to solve for x. If you have forgotten the steps to solve for x, go back in my videos and watch the one over solving multi-step equations. And I go through all those steps. So we do not have the distributive property here. We cannot combine like terms on each side, so we're going to move all our variables to the same side. I like to move the smaller one, but if I move this, there's not going to be anything over here, so that really isn't going to help me solve. So I'm going to move this. So I'm going to subtract 5x because I'm going to move this entire term. So I'm going to subtract 5x from both sides. And that leaves me with a minus 76 equals a negative 2x. I want to find out what x is. It's a negative 2 times x. So I'm going to do the inverse and divide both sides by a negative 2. And a negative divided by a negative is going to be a positive. And 76 divided by 2 gives me 38. So x is 38. Now that's if they asked me to solve for x. Now if they asked me to find the measurement of these angles, first I'd want to solve for x. And then I would take one of these and I would substitute what I found x to be in place of x. And so I would do 38 times 3. So 8 times 3 is the 24, so I'd carry that 2. 3 times 3 is 9, 10, 11. So the measurement of those two angles would be 114 degrees. So always look at what it's asking you for. If it's solving for x, you just solve for x. If it wants to know the measurement of the angle, then you might have to then substitute it in to find that out. Okay, let's look at another example, and I'm going to sketch out this one. So we have for two parallel lines, and we have a transversal going that way. Okay, so let's see what's happening here. The two angles that they have given us are, right here we have 3x minus 1. And then right here we have 4x plus 13. Okay, those two angles are not the same. They're not the same measurement. I mean, even if you look, this is a small angle, an acute, and that's an obtuse. So they're not the same. Plus, they're not alternate interior because they're both on the same side of the transversal. They're not corresponding, both being on the same side of the transversal, because that one's below a parallel line, whoops, and that one's above. So instead, they have a sum of 180, like this. Okay, so every time your two angles are either going to be equal to each other if they're the same measurement, or they're going to have a sum, which is mean you add them, of 180. So now I'm going to follow the steps for solving a multi-step equation. Okay, I don't have a parentheses to do distributive property. I can combine like terms over on this side. I can combine my 3x and my 4x to get 7x. And my negative 1 plus 13 is a positive 12. And now I'm going to go through and do inverse operations. I'm going to do the inverse of adding or subtracting, and subtract 12 from both sides. And the inverse of multiplication would be to divide. And I don't have a calculator, so let's see. 7 divided into 168 would be 24. So x is equal to 24. Once again, that's if they ask for x. If they want to know what the measurement of the angle is, you would take 24 and substitute it in for either of these x's. So I might pick that one and say 3 times 24 minus 1. 3 times 24 is 72 minus 1 tells me that that angle is 71 degrees. This angle is then 180 minus 71, because if they're not the same, they have a sum of 180. So this angle right here would be 180 minus that 71, which is 109 degrees, would be that one. Most of the time, they're just going to ask you to solve for x. Okay, next, let's look at an example with triangles. Okay, every triangle you have has a sum of 180 degrees. So this angle plus that angle plus that angle equals 180. These two angles, here and here, when you add those two angles together, they're going to equal that angle. And that's something else that you can think about. The sum of these two is going to equal that one. All right, so if you have a picture, something like this, and you're told that this angle is 30 degrees, and this angle is 30 degrees, and they want you to find that one. Well, obviously that would mean this one would have to be, this is not an accurate picture, but you would say 30 plus 30, that's a 60-degree angle. Okay, let's look at another quick example. Okay, if this was 120 degrees, and this angle right here was 45 degrees, then I can find every other angle here, and this one and that one. The sum of these two equals 120. So I could do 120 minus 45 and get to 75, and this angle then would be 75. Okay. To find out what that one is, you would add your 75 plus your 45 and then subtract that from 180, and that would tell you that that angle right there is 60. Every triangle is 60 degrees. Okay, 60 degrees, 180 degrees. Every triangle is 180. Okay, let's look at our last example of what's going to be on your test. I want you to look at this angle right here, or this triangle, and let's say it is called A, B, C. And then you have this triangle here, and D, E, F. And I said triangle ABC is congruent, similar to triangle DEF. What that basically is telling you is this angle is in the middle, so it's here. And this angle is in the middle, and it's here. So those two angles have the same measurement. Another example would be angle A is first, angle D is first. So those two angles have the same measurement. And last but not least, this one and this one, they're both third. And so they have the same measurement. So always look in the order they come. If this angle is 45, then angle D is 45, because they were both first in order. Angle ABC, ABC, B is the angle they're actually referring to at that time. Whatever letter is in the middle would be the angle they are referring to. All right, I hope this helps you some on your test tomorrow. And so I want to wish you the best of luck. Thank you.